At 13:47 hours in occupied Zaporizhia, 12 Ukrainian drones were screaming toward a Russian ammunition train at 97 kilometers per hour. But the operators controlling them did not know that Russian artillery had already found their position. The first 152mm shell landed 800 meters away, close enough to shake dust from the ceiling. The Russians detected them the moment 48 brushless motors powered up simultaneously. That electromagnetic spike lit up every sensor within 10 kilometers like turning on stadium lights. The operators had a choice: abort and survive, or continue while under fire. They had roughly 12 minutes to reach the train. The Russian artillery needed maybe 3 minutes to find them. They decided to continue the mission. The BTR-82A spotted the drone swarm and opened fire. Tracers arced through the morning air. The formation split instantly. 4 high, 4 low, 4 straight through the middle. Machine gun rounds zipped through empty space. But here is what the Russians could not see. Each drone trailed a fiber-optic cable thinner than a fishing line, while Russian jamming flooded every frequency with 10 kilowatts of interference. These cables carried data at light speed, completely immune. The $10 million electronic warfare vehicle below them might as well have been a very expensive paperweight. While the drones were on their way, Russian artillery had found the operator's exact location and started pounding the position. But the Ukrainian operators had prepared for this. They positioned themselves in 3 separate bunkers spaced 500 meters apart, and here is why that specific distance mattered. A 152mm artillery shell creates a lethal radius out to 300 meters at 500-meter spacing. Even a direct hit on one bunker would not affect the others. The Russians could eliminate one bunker, maybe 2 with incredible luck, but never all 3. 8 drones would always survive to complete the mission. The second round landed 600 meters away, closer but still searching. Through the lead drone's camera, the operator could see the target clearly now. Black diesel smoke rose from the train. It was approaching an area where the track ran straight for 2 kilometers through open terrain, too far from defensive strongpoints, too exposed for close protection to matter. The Ukrainians had studied this route for weeks. The window would last exactly 97 seconds. The third round impacted 450 meters away, and this one changed everything. Shrapnel from the explosion whizzed through the air at 1,500 meters per second, and 3 pieces found their marks. The fiber-optic cables of drones 2, 5, and 8. The cables, only 8 millimeters thick, severed instantly. These 3 drones immediately switched to backup battery power and radio control. But that meant they were now vulnerable to jamming. The other 9 drones, their fiber-optic cables intact, continued transmitting data through pulses of light racing through glass at 200,000 kilometers per second. The operators in Bunker 1 made the call to continue the mission while relocating. As they grabbed their equipment and moved to the backup position, the 4th artillery round slammed into the ground just meters away. But they were already gone. Sprinting through the connecting tunnel to Bunker 4 700 meters to the east, the artillery would have to reacquire, and that would take time they did not have. Though 3 drones were now vulnerable, the 9 still connected by fiber-optic cables were completely immune to the electronic warfare. Radio signals travel through air and can be disrupted by flooding those frequencies with noise. But fiber-optic cables transmit data as light bouncing through glass fibers. Jamming radio waves to stop a fiber-optic signal is like trying to stop someone shining a flashlight by shouting at it. The physics simply do not interact. The 3 drones on radio backup, however, were about to face their first real test. The R-330ZH ZAL electronic warfare vehicle, positioned at the rail junction, detected the drone swarm at 7 kilometers and immediately activated its transmitters. 10 kilowatts of electromagnetic energy flooded every frequency from 100 megahertz to 2 gigahertz. Enough power to overwhelm every commercial drone control channel, GPS signal, and radio communication within 30 kilometers. The 3 drones running on radio backup after their cables were severed went dark instantly. Their screens turned to static, but the other 9 kept going on. Inside the Zatel's command cabin, the operator watched his waterfall display change as the system began pumping out even more energy. Every frequency was saturated with its jamming signal. He had successfully created an electromagnetic bubble 30 kilometers wide. On his scope, 3 drone signals had winked out instantly, but 9 others kept coming, their signals impossibly clean. He checked his equipment, confused. How were they still transmitting through 10 kilowatts of jamming? The operators tried switching frequencies from 2.4 gigahertz to 5.8 gigahertz, and every known military band. Soon, the Zytel was broadcasting noise across the entire spectrum. It was like trying to have a conversation in a room where 1,000 speakers were playing different songs at maximum volume. The 3 drones on radio control were now flying blind, continuing on their last heading until their batteries died or they hit something. But here is the ironic side of electronic warfare. It is indiscriminate. The Zytel massive jamming field did not just affect Ukrainian systems. The BTR-82A crew at Checkpoint 9 could see the drone swarm approaching on thermal imaging and tried to radio a warning to the Panzer S-1 air defense system 3 kilometers away. Nothing but static. Their military radios were just as dead as the Ukrainian frequencies. The Russians had blinded themselves while trying to blind the enemy. The 9 drones with intact fiber-optic cables flew on completely unaffected. The Zytel could pump out 100 kilowatts and it would not matter. The $10 million electronic warfare vehicle designed to knock NATO drones out of the sky at 30 kilometers was absolutely powerless against drones connected by what was essentially very long fishing line. The train engineer, warned about possible drone activity during his mission briefing, pushed the throttles forward. The convoy accelerated from 42 to 48 kilometers per hour, then to 52, finally maxing out at 56, the absolute limit for 4,000 tons of cargo on aging track. But acceleration created a new problem. Every kilometer per hour faster meant the intercept point shifted 17 meters further down the track. The Ukrainian operators had to recalculate continuously, each course correction burning battery power they could not afford to spare. The BTR crew at Checkpoint 9 had exactly 8 seconds to engage. That was how long the drone swarm would remain in their engagement envelope, as it crossed perpendicular to their position. The gunner traversed his turret, trying to calculate the lead angle for targets moving at 27 meters per second. At that speed and angle, he needed to aim 15 meters ahead of where the drones were. He opened fire with the PKT machine gun, 800 rounds per minute, arcing through the afternoon air. By the time he calculated the proper lead and walked his fire onto the flight path, the swarm had passed behind a tree line. 8 seconds to acquire, track, lead, and engage 9 targets the size of dinner plates, moving faster than highway traffic. The geometry was impossible. Every round missed. The BTR gunner had trained for this scenario countless times in simulators, but reality was different. In training, targets moved predictably. The drones jinked randomly every 2 seconds, up, down, left, right, like drunken hummingbirds. Through his sight picture, he could see the fiber-optic cables trailing behind them, glinting in the afternoon sun like spider silk. He tried to lead them properly, but it was like trying to shoot the shadow of a bird. By the time he aimed where it was going, it had already changed direction. The BTR commander pounded his fist on the turret. He could not even report the miss, because the radios were still jammed. The 9 surviving drones pressed on toward the train, now 4.2 kilometers from intercept. But the Panzer S-1 air defense system at the rail junction had detected them on thermal imaging. The radar, designed to track cruise missiles, filtered out the tiny drone signatures as ground clutter. The operator switched to electro-optical mode, manually tracking the incoming swarm through what was essentially a very expensive telescope with guns attached. But despite this, the Panzer would prove that sometimes one lucky shot is all that is needed. The Panzer twin A38M autocannons opened fire at 3,200 meters, but the gunner was not trying to hit individual drones. That would be like trying to shoot mosquitoes with a rifle. Instead, he set his 30mm shells for airburst detonation. Each round was programmed to explode at a preset distance, fragmenting into 400 pieces of steel shrapnel in a 4-meter sphere. At 5,000 rounds per minute, he was creating a wall of metal between the drones and their target. Drone 6 vanished in an orange fireball at 2,900 meters. 3 seconds later, Drone 11 exploded. The 7 surviving drones immediately scattered in 3 dimensions. 3 climbed to 200 meters, 3 dove to grass height, and 1 maintained altitude while zigzagging laterally. This forced the Panzer gunner to make a choice. The Panzer was designed to stop Tomahawk cruise missiles and F-16 fighters, threats that behave somewhat predictably. But these drones moved like angry wasps, and the gunner faced an impossible decision. His computer recommended engaging the high group because they were easier to track against the sky. His training said, engage the closest threat first. He had 2 seconds to decide. He chose the high group, not knowing he had just repeated the same mistake that had cost another train 3 weeks before. He elevated his barrels toward the climbing group, committing to that target set. Classic error in air defense. You always engage the closest threat first because it has the least time to react. While the Panzer barrels tracked upward chasing the climbing drones, the low-altitude group accelerated toward the train, unbothered. The gunner realized his error, but could not traverse fast enough to reacquire. The low drones were already past his optimal engagement angle. But this was not the only wall of lead the drones had to fly through. As they closed in on the tracks, a platoon of Russian soldiers at Observation Post 7 added their firepower, 40 AK rifles firing in synchronized bursts. But the shot was nearly impossible. The drones were crossing perpendicular to their position at 27 meters per second. At 200 meters distance, each drone spent exactly 0.74 seconds in a soldier sight picture. Human reaction time is 1/4 of a second. Target acquisition and aiming takes another half second. By the time a soldier could squeeze the trigger, the drone was already gone. Meanwhile, 4 special drones that had been flying at 500 meters altitude dove toward the railroad tracks 800 meters behind the speeding train. They released their payload simultaneously, thermite charges that ignited on impact with the rails. Thermite is not an explosive. It is a mixture of aluminum powder and iron oxide that burns at 2,500 degrees Celsius. Railroad steel melts at approximately 1,370 degrees Celsius. The thermite ate through the rails like acid through paper, transforming 4 sections of track into puddles of molten metal within seconds. As the drones continued their approach, the Panzer barrels glowed cherry red from sustained fire. Modern autocannons can maintain maximum rate of fire for approximately 45 seconds before heat warps the rifling. After that, rounds tumble. Instead of spinning, and accuracy becomes worthless. The gunner had no choice but to cease fire for cooling. This created a 12-second window, an eternity in combat where the sky was clear. 7 drones pushed through the gap. Battery warnings flashed amber on the operator screens. The fight against headwinds and constant course corrections had drained power faster than calculated. Drone 3 showed 18%, Drone 7 21%. They needed 30 more seconds to reach the train, but had maybe 20 seconds of powered flight remaining. Smoke from the thermite-ignited grass fires drifted across the battlefield on the afternoon wind. Thermal imaging can see through darkness, rain, and fog, but not through smoke. The carbon particles absorb infrared radiation across all wavelengths. For those crucial seconds, every Russian defense position lost visual contact. The drones punched through the smoke at 1,400 meters from target. Their cameras showed individual details on the train cars, unit markings, rust patterns, and even the white stencil warning on Wagon 22 Class 1 explosive. The fiber-optic cables were approaching maximum extension. At exactly 12,000 meters, they would release automatically to prevent tangling. 10 seconds to release. 5, 3, 2. The first cable released 13 meters short, using a simple spring-loaded mechanism originally designed for fishing reels. Drone 1 transitioned to battery power, now at 8%, remaining enough for maybe 18 seconds if everything worked perfectly. The other cables released in sequence over 3 seconds. The drones were now flying free, no longer immune to jamming, but also too close to stop. 1,530 meters from impact, and closing at 27 meters per second, the train engineer saw them through his windscreen. 7 black dots growing rapidly larger against the afternoon sky. He slammed the throttle forward past the mechanical stops, overriding every safety governor. The diesel engines immediately redlined, but pushing harder made things worse. The driving wheels lost traction and began spinning on the rails. Steel on steel has a coefficient of friction of 0.78 when static, but once the wheel starts slipping, it drops to 0.25. The harder he pushed, the more the wheels polished the rails instead of gripping them. The train actually lost 2 kilometers per hour, but he kept going. The Panzer attempted one final engagement, but the drones had entered its minimum range, 500 meters, where the autocannons could not depress below -5 degrees. The system was designed to engage cruise missiles and aircraft approaching from above, not ground-skimming drones. $20 million of air defense technology, defeated by basic trigonometry. The gunner could only watch his screen as 7 drones disappeared below his engagement envelope. Russian soldiers at the final checkpoint opened fire with everything they had: machine guns, AK rifles, even RPG-7s, detonated as improvised flak bursts. But the drones were following the exact center line of the railroad tracks, using the 600-meter train as cover from lateral fire. To hit the drones, the soldiers would have had to shoot through their own train. The geometry protected the attackers perfectly. Drone 3's battery died completely at 100 meters from the target. The motor stopped instantly, propellers windmilling uselessly, but the drone's momentum carried it forward. At 97 kilometers per hour with minimal air resistance, the dead drone would glide the rest of the way before aerodynamic drag could stop it. The operator had calculated this perfectly. The drone would coast the final distance on physics alone. Through the last functioning camera, the operator watched Russian combat engineers attempting to decouple Wagon 22 while the train was moving. The coupling was under 4,000 tons of tension at 56 kilometers per hour. The safety mechanism was specifically designed never to release under load, preventing catastrophic separation during normal operation. The engineers might as well have been trying to untie a knot made of steel while it was being pulled by bulldozers. Drone 9 caught a lucky burst from a PKM, shrapnel clipping its battery pack. It tumbled into a wheat field 400 meters short. 6 drones remained. The operators had calculated for 60% losses from the start. They only needed 4 hits to achieve mission success. The margin was still positive. At 13:59, the lead drone slammed into the coupling between the locomotive and the first wagon. The RPG-7 warhead detonated on impact. Its shaped charge created a jet of molten copper, moving at 2,800 meters per second, 9 times the speed of sound. The massive steel coupling pin sheared instantly. 4 more impacts followed in precise sequence. Wagon 3's fuel valve assembly ruptured, spraying pressurized diesel. Wagon 7's brake line severed, locking every trailing wagon's wheels. Wagon 18's thin-skinned ammunition car took a direct hit, starting a chain of secondary explosions. Wagon 22's ventilation system was penetrated at 13:51 and 18 seconds. Inside Wagon 22, 12 tons of TOS-1, a thermobaric rockets had been slowly heating from vibration-damaged seals. The warhead impact pushed the internal temperature past 447 degrees Celsius, the auto-ignition point. The fuel-air mixture detonated with a pressure wave propagating at 3,000 meters per second. Wagons 20 through 24 simply ceased to exist, vaporized into plasma. The blast wave lifted wagons 25 through 47 completely off the rails, flipping them end over end across the countryside. The mushroom cloud climbed to 1,400 meters. In 4 seconds, $4,800 worth of modified racing. Drones had erased $127 million in Russian military assets and severed the only rail line feeding 3 mechanized divisions preparing for the prostate. Next day's assault. End of transmission.